Zeros of a polynomial. Now in this example we're given that 2 plus I is a root of pz equals z cubed minus z squared minus 7z squared plus 17z minus 15. We have to find the other zeros. Now if this is a root, then the conjugate will also be a root. So we've got z1 would be equal to 2 plus I. So z2 would be equal to 2 minus I. Now, what we can do, we can form a little quadratic, and we can say that, we'll call this P, I don't know, W or something. That would be equal to Z squared minus the sum of these roots, Z1 plus Z2, plus the product of these roots, Z1, Z2. Now, that gives me the sum. If we add these two together, I get 2 plus I and 2 minus I. That will give me just 4. So it's 4, and for Z, should be a Z there, sorry, plus, and the product of these two, 2 plus I times 2 minus I, that'll be 4, and this will be I times minus I is going to be 1, so the total will be 5. So there is our little mini polynomial there, rather quadratic. Now we can then, we could do long division, but that's a bit awkward. So what we can do now is we can say that Pz is equal to Z minus some value A times this one here, Z squared minus 4Z plus 5. Now I can say it's Z there, not 2Z, because we can see it's a monic polynomial. So that's absolutely fine. Now, what we can do now is we can replace, should I put this over this side? Never mind. I'll just put that in now. That's Z cubed minus 7Z squared plus 17Z minus 15 equals all this stuff. Z squared minus 4Z plus 5. Okay, so what we can do now, because this is an identity, we can put in any value we like. So the simplest value to put in is obviously 0. Putting 0 in here, we just get minus 15 on the left-hand side. And putting 0 in here, we're going to get minus A times 0 in here times 5. Okay, so then we divide both sides by, it becomes 15 equals 5A. So A is equal to 3. So now we know the three roots are Z1 is equal to the original one, which is 2 plus I. Z2 was equal to the conjugate, Z minus I, and Z3, the real bit, just 3. Done. In this next example, we are given that Pz equals 16Z cubed minus 12Z squared plus 1 has a multiplicity of 2. We have to find the roots of Pz. Now to do that, first of all, we differentiate this function. We get P dash Z equals 16 times 3 is 48, 48Z squared minus 24Z. Then that equals 0, we get 48Z squared minus 24Z equals 0. Taking the 24 out as a common factor, we get 24Z out as a common factor rather, we get 2Z minus 1 equals 0. Therefore, Z equals 0 or Z equals a half. Now, quite clearly, Z can't be equal to 0 because you've got this 1 here. So putting Z equals a half into that, we get that P half equals 16 times 1/2 cubed minus 12 times a half squared plus 1, and that will give me 0 on the calculator. Alright, now we know then that Z minus 1 is a factor, and also it's a double root, so therefore we can say that 16Z cubed minus 12Z squared plus 1 will be equal to 2z minus 1 times 2z minus 1 times, now you notice here that you've got a 16, so 2 times 2 times 4 will be in here, plus some constant a. Same deal, we'll put in, of course it's an identity, we can put in zeros, and I get 1 is identity equal to, this becomes minus 1 times, and this becomes just a, therefore a must be equal to 1. So this 0 here is, or factor rather, is 4z plus 1. Now when that equals 0, we can see that z equals minus a quarter. So our roots are z1 is equal to a half, z2 also equals a half, and z3 equals minus a quarter. Done.